And tonight we're going to finish up with electrochem, and we are, I think, on Roman numeral 5, at least is what I have in my notes. And our discussion tonight is electrolysis. And electrolysis is simply electrical energy. So again, electrical energy causing a non-spontaneous reaction. A non-spontaneous reaction to occur. Alright, so it's basically the exact opposite of a galvanic cell or a voltaic cell. And again, both of those happen spontaneously. Electrolysis is causing the reverse reaction to happen. Alright, this is how rechargeable batteries work. Batteries, obviously, there's a flow of electrons because two metals are giving up their electrons. Well, if you plug that back into the wall, it makes the electrons go backwards, and then you use your battery again, and the electrons go forward in a spontaneous reaction because it's a galvanic cell, and then you electrolyze those electrons back, and so on and so forth. Alright, so we kind of have a new unit to introduce, and that new unit is the amp. That's kind of the shorthand for it. It's really known as an ampere. We just usually call it an amp for short, and it is a measure of current. And typically, if someone gets electrocuted, and the volts can be really, really, really high, but usually if the amps are high, having a high amperage and getting shocked with a high amperage is typically what kills you. And again, it's a measure of current, and it's related to coulombs in that 1 coulomb equals 1 amp times 1 second. And usually we're going to see it like this, where an amp, 1 amp equals a coulomb per second. Alright, so really we'll talk about amps as being coulombs per second. And then the next thing is basically solving electrolysis problems. Solving, I don't know, math problems, or let's call it solving electrolysis problems. Alright, your book lays this out really nicely in a nice flowchart. It is figure 19.20, 1920. It's on page 851. You might refer to this if you have your book at home with you, or if you have it at school. Kind of make note of this. It's a nice little figure that pretty much, they're all basically solved the same way. And it's very much one of these things where look at the units you have, what are the units you need to go, what are those units, and then it's going to be kind of a long fence and rail type problem, or just really a stoichiometry type thing. Most of the time, we can kind of start from one end to the other, so these steps can be reversed. But the first thing is typically convert amps into coulombs. And in order to do that, we need to use time. So convert amps into coulombs using time. If we have time and amperage, we can get coulombs. Typically the next step is going to be converting coulombs into moles of electrons. And how do we do that? We use Faraday's constant. Using Faraday. I'll go back to all caps because it's starting to look messy. Alright, the next step is converting moles of electrons. Converting moles. I'm not going to go back to whatever caps. Convert moles of electrons into moles of our substance. Alright? And this is going to typically be used, or we can do this using our half reaction. And then our last step usually involves converting moles into grams. Convert moles not moles of electrons, but regular moles, into mass using molar mass. But again, figure 19.20, page 851, does a pretty good job of explaining that. Alright, we're going to make this page a little bit bigger. There we go. Alright, so our example is going to be a little bit different than the one in the book, just so you got something different. We are going to think about calcium chloride. And it's going to be molten. Alright, so it is essentially going to be, it's a salt, so it has a really high melting point, but we're going to melt that salt and really melt it into calcium ions and chloride ions. So we have molten calcium chloride, and we're going to suppose a current of 0.452 amps is supplied for 1.5 hours. How much product will form? Alright, so real quick, our overall equation is going to be calcium ions, and then we have some chloride ions, are going to make just calcium and some chloride gas. Alright, so to balance this, and this is actually calcium is a +2, we need that, and we are good. So if we want to write our two half reactions, our first half reaction is going to be calcium ion is going to turn into calcium metal, and our other half reaction is two chlorides are going to turn into chlorine. On the bottom one, we have electrons on this side. On our top one, we're going to have electrons as reactants. So if we identify these, this is our reduction reaction, and this is our oxidation reaction. Alright? So a couple things. We're going to use time in amps, and let's just figure out what our calcium product is going to be first. So we have 1.5 hours, and we need to get this into seconds. So an hour has 60 minutes, and a minute has 60 seconds. So 1 hour consists of 3,600 seconds. And then our next thing is our amperage, and amps is always coulombs per second. So we're going to have 0.452 coulombs per second. Alright. And then our next thing is going to be Faraday's constant, and Faraday's constant says that for every mole of electrons, they carry 96,500 units of energy, not really units of energy, but coulombs. And now we are talking about our redox reaction, because we're going to do calcium first. So there are 2 moles of electrons. Notice here, 2 moles of electrons for every calcium, or for every mole of calcium moles. And then lastly, 1 mole of calcium clocks in at 40.08 grams. So notice things that cancel, our hours are going to be gone, our seconds are going to cancel out, our coulombs are going to cancel out, our moles of electrons are going to cancel out, our moles are going to cancel out, and we're going to be left with grams, which is what the problem's asking us for. And if we do that math, we're going to find out that we can produce 0.507 grams of calcium in an hour and a half's time. Alright, same thing for chlorine. Let's leave our chlorine reaction up there at the top, and here we go. Still same amount of time, so 1.5 hours, and there are 3,600 seconds in an hour. And our amp is staying the same, 0.452. Whoops. 0.452 coulombs per seconds. Faraday's is the same, 1 mole of electrons can conduct that many coulombs of electricity. And then for calcium, we're going to see that we have, again, 2 moles of electrons for a mole of chlorine. Alright, it is a diatomic element, so I'm going to come in here, 1 mole of chlorine weighs how much? It's going to be 35.453 times 2, so we're going to say 70.9 grams. And again, we're going to do all the multiplication, and we're going to get 0.896 grams of chlorine. Alright, that is pretty much electrolysis. The main thing is just, it's always going to be solving. The steps are pretty much the same. You might start with mass and work your way backwards and find out either how much time it takes, or you might they might give you time, you have to find out what the amperage would be, and that is pretty much it. So again, that wraps up electrochem, the last big thing that you have to learn for chemistry, and have a great night.